Hi everyone, I'm Zhang and I'm going to present our work learning rule embeddings over knowledge graphs, a case study from e-commerce entity alignment. This is a joint work from Zhejiang University and Alibaba. Our task is entity alignment rule learning in e-commerce knowledge graph application. Previous work showed that rule learning and embedding-based method help the development of knowledge graph largely. While we couldn't directly apply them in our scenario because embedding-based methods with promising performance are unexplainable, while explanations are quite important in real-life applications. And existing rule learning methods often suffer from efficiency problems because of huge search space. Thus, we propose a rule learning method called Rule E that combine these two methods by learning rule embeddings. In Rule E, we present target rules, item properties, values as vectors, and they are the main inputs of our model. There are mainly three modules. The first one is PS module, which will generate a score S1 to evaluate whether the input property is included in the rule. And the second one is PC module, which will generate a score P to estimate whether the value of input property should be same if it is included. And the third one is VD module, and to decode a specific value for the input property and generate a score S1 to evaluate whether this decoded value matches with the input value. Then, with S1, P, and S2 from three modules, we calculate the score Sij, indicating that whether the input property and value pair from the two items satisfy current rule. As an item pair to be aligned usually have multiple properties and value pairs. Thus, we combine all the score ij to generate a final score evaluating whether the input item pair satisfy the candidate rule. During experiment, we utilize one real-world item alignment dataset generated from e-commerce platform Alibaba to evaluate Rule E. We compared our method with three KG embedding approaches and two graph embedding approaches. The experiment result showed that our Rule E outperforms baselines among all evaluated metrics. And we also decode symbolic rules from learned rule embeddings. In our model, each learned rule embedding could generate one symbolic rules. Here we give two decoded rule cases. The first one means that if two items have the same product barcode with value listed here, then they are the same items, which quite makes sense. And the second one means that if two items brand are the same with value Coca-Cola or Pepsi, and they have the same weight property value, then they are the same items, which seems to make sense. And we also evaluate the quality of rules with support, confidence, and head coverage metrics. And we find that these alignment rules has high confidence. Although the coverage ratio of one rule might be low, but combining all the generated rules, we can cover most instances in the dataset. Thus, we could conclude that Rule E is capable of doing item alignment tasks, and the idea of learning rule embedding works. It is work. And thanks. If you are interested in Rule E, please refer to our poster paper. Thanks.